Right, so tonight's assignment is the practice test. And then the test is not this week, right? Who looked at, here, I'll look at the assignment sheet then. Period 1. The test is next week, Tuesday. Tomorrow, wait, what is today? Yeah, tomorrow we start the next chapter on sequences. Alright, now there's two problems that are going to be on the test. I just want to go over them today and make sure you can do them. One of them is the birthday problem. Oh, look at these pieces of chalk, little junk. So, let's see if you guys remember how to do the birthday problem. Let's say 5 people are randomly selected. 5 people randomly selected. And we're going to assume that being born in a particular month is the same as any other month. So the probability of being born in any month is 1/12, although that's not true, but we're going to assume that. So if 5 people are randomly selected, compute the probability that at least 2 people share the same birthday. The same birth month, rather. Birth month. Okay, you guys remember how to do the birthday problem? Because the birthday problem is going to have a little twist in it. So you got to know how to handle the regular one if you can do the twist. So what do? Here are the 5 people. And then what do I write inside? How many months are there in the year? Okay, it took that long. So what's the probability that somebody's born on a month?
12 out of 12.
12 out of 12. What's the probability that the next person is born in a different month than the first person? 11 out of 12, then 10 out of 12, then 9 out of 12, then 8 out of 12. So if you multiply these numbers together, that is the probability that these 5 people all are born in a different month. So how do you get the probability of at least 2 are born in the same month? You subtract it from 1, because that's the complement. The complement of these 5 people all are born in a different month is at least 2 of them are born in the same month. Okay, that's the birthday problem. What kind of twist can Mr. Park pull? Well, you'll have to take the test to find out. And the other one is tossing a coin, remember? Like we did yesterday. But you're not going to get a square, okay? It's not going to be a square. In fact, I showed you yesterday, but I don't know if you guys remember. Now, you guys are going to do this. I'm not going to do this. You guys are, I'm going to question some people. So suppose this is 36 by 36 inches. And we're going to assume a quarter, which has 1 inch diameter. We'll assume that it lands completely in this region. What is the probability that it lands in an equilateral triangle? I showed you this yesterday, but again, you got to be able to do it on your own. And what are the dimensions of this equilateral triangle? Why don't we say 8 by 8 by 8 inches? Okay, so if I randomly toss this coin in here, what's the probability that it will land completely in this shaded region here? Okay, you guys work. Pretend this is the test. Right now, do it on a piece of paper or your iPad. It was only 24 hours ago. At least it which has an area, for those of you who forgot, you gotta ask yourself, where does the center of the coin have to land? Because that's a single point. You're gonna have to know geometry for this one. You're gonna have to know geometry when you take calculus. Okay, what did we get for the denominator at least? Cruz, denominator.
1225.
Okay, I guess. I was just thinking 35 squared. 1225 is correct. Everybody got 35 squared? You might as well leave it 35 squared because you know why? You might have to cancel, that's why. So it's easier to cancel 35 times 35. Everybody understand why it's 35? Because the coin has to be completely in this region. So that means the center of the coin has to land half an inch inside the border. So it's going to be 35 by 35, right? Okay, the hard part is the triangle. So yeah, I'll probably give you 1 point for the denominator, but what about this? Where does the center of the coin have to land? So it's got to be half inch from the border. So it's kind of like this, right? So the center of the coin has to land in a smaller equilateral triangle. This was the problem last year. I just alternate shapes every year. So how do you find the area of that smaller equilateral? Mr. Park said something about 30, 60, 90 triangles. Well, this is a half. Okay, well, if you know this is a half and then you draw this in, isn't that a third? Here, let's blow it up. And I don't mean explode it, I mean make it bigger like that. You have a 30, 60. How do we know this is 30, 60, 90? Because it's equilateral, right? This angle is 60, you bisect it, you get 30. So this is 1/2. So in a 30, 60, 90 triangle, what do we need? We need to get the side of the equilateral triangle. So we need to know this. Well, if this is 1/2, how do you get the longer leg? You multiply it by root 3, so it's going to be root 3 over 2. So that means this is root 3 over 2, and then this is root 3 over 2. So the side of the inner equilateral triangle, isn't it going to be 8 minus 2 root 3 over 2's? Yeah, which is 8 minus root 3. And if you know the side of an equilateral triangle, how do you find its area? I hope you remember. I'm telling you, it's going to come up in calculus a lot. Root 3 over 4 times the side squared, and the side we just figured out is 8 minus root 3. Is that an acceptable answer? I don't think so. I think we need to simplify this. So what do we got? We got root 3 over 4, and then now you got to multiply this out. 7 root 3 minus, what is root 3 times 16 root 3? 48 all over, and then of course the 1/4 goes in the denominator, so you actually got to multiply 1225 times 4. Come on, you can do it. Think of this as 1200 plus 25. Distribute the 4. 4800 plus 100. Pretty. 4900. Okay, do whatever it takes. There you go, that's the answer. Darn it, I was hoping we could cancel some more. Maybe if I'm pretty sure last year I made it a different side so that when you simplify you can cancel even more. That would be better. But you gotta do what the problem tells you to. So could you repeat this on the test? What if it's a hexagon or octagon? In fact, here, this is just for funsies. Would you know how to find the area of an octagon if you knew the side? Let's review some geometry. No, I'm serious, in calculus, you gotta know geometry. Okay, octagon, stop sign. That's what Mr. Masanaga calls it, right? Okay, give me the side. Give me a number.
2.
2. Okay, you have an octagon of side 2. This is a regular octagon. How do you find the area? Okay, you're in a Turkish prison. The only way I'm going to let you go is you're going to tell me the area of this. What are you going to do? I think I'll just stay in prison. Or do you want to get out? I am in prison, Mr. Park. Come on, what did your geometry teacher tell you? Break it up into things that you know. How about this? I guess I'm your geometry teacher. Put a square around it. Find the area of the square and then subtract 4 congruent right triangles. Yeah? This is like SAT. You break it up into pieces. Okay, now can you find the side of the square? Well, we know this is 2 and this is 2. Okay, boom! I got it. So what kind of triangle is this right here? These 4 triangles. Is it 30, 60, 90? It's 45, 45, 90. So in a 45, 45, 90 triangle, if you know the hypotenuse, how do you get the leg? Come on, this is SAT. Come on the directions of the SAT. Don't they have this? 45, 45, 90. S root 2, right? So if you know the leg, you got to multiply by root 2 to get the hypotenuse. If you know the hypotenuse, then what do you do? Divide by root 2. So what is 2 over root 2? Really? Root 2. So what's the side of the square? Look, it's right there. 2 plus 2 root 2. That's the side of the square. And then you square it. That will give you the area of the square. And then you got to subtract 4 of these triangles. So 4 times, how do you find the area of a triangle? 1/2 base times height. 1/2, what's the base? Root 2, what's the height? Root 2, so root 2 times root 2, and then can I trust you to simplify that? Okay, just for funsies, why don't we simplify this? So what we've got to do is we've got to multiply this out. Again, multiply out. 4 plus
8 root 2.
8 root 2 plus 8 minus, and then who got the easy one over here? Calabrese Kenny. You got the easy one. Simplify that. 4. So the 4's cancel out. Final answer, 8 root 2 plus 8. Make it look nice. Box that, that's the answer. people on the video, who's watching the video, the online students. This is for you. Oh, we should find a way they can play. Oh, they missed out a bit. I don't think I covered this part of the board. Darn it. Yeah, but they're watching from China, so then they're probably sleeping right now, yeah? Yeah. Okay, anyway, I got this online. These, okay, who won yesterday's game?
Boys.
Boys. Is it always the boys? Okay, these are the favorite colors of people. There was like a vote. Oh, I don't know, 12,000 something people. Favorite colors. Okay, girls, you start on this side. Girls.
Maybe blue.
You don't have to be that specific.
Oh, okay.
Okay, blue, number 1. Boys. Black. Oh, there it is, number 4. Girls.
Red.
Red. Number 3. Girl. No, boys. Yellow. Is that what you said? Yellow. 11. Girls.
Green.
Green. 2. Oh, you guys are good. Boys. I forgot where we are. Boys.
Purple.
Purple. 5. Girls.
Yellow.
Somebody said yellow.
Orange.
Orange. Orange is not on this list. There's only, I don't know, it only goes up to 14. So we'll give it 15. Boys.
Pink. Pink.
Pink. 7. Girls.
White.
White. 9. Boys.
Purple.
Didn't somebody say purple? Come on, pay attention. Or like my wife says, pay attention.
Orange.
Didn't somebody say orange? Okay, but we're gonna have to just go with that. Not on the list. If you don't pay attention, then it's your fault. Girls. Girls? Huh?
Brown.
Brown. 6. Boys.
Magenta.
Magenta. Not on the list.
No. No colors in there.
Girls? Where? Girls?
Indigo.
Indigo.
Is that?
I don't have to look, not on the list. Boys? Boys?
Red.
Phone a friend? What?
Red.
Orange.
Red.
We already had that.
Is there anything else?
Yeah. Okay, the ones that are left. No. Some of them are like, I have to look up what they are. That's the only hint I can give you. No phoning a friend.
Just give me not all of these. I don't know. I don't think I can guess any of them.
Okay, here. I see it in this room.
Gray.
Say that again?
Gray.
What?
Green.
Oh, gray. Number 10. Girls, where are we?
Beige.
Beige, there you go, number 8. Beige, number 8. Isn't this kind of beige? Not really. Boys. And the boys win, no, it was a lost cause. Okay, you guys got everything in the top 10. The ones you didn't get are 12, 13, and 14. Mauve. What is mauve? It's like a lighter shade of purple. Fuchsia. Anybody?
Light pink.
Bright pink. Didn't somebody? That's kind of like magenta then. And then maroon. Okay, whatever. That name didn't go that well. All right, we're done. It's hard coming up with games. Me. Hey, did I tell you last?